let's talk about your review real fast. So remember 12.1 was the simple probability, and the odds questions, simple probability, like you're taking this out of a box or you're taking this out of a bag, that kind of stuff. And then odds, remember odds we want to put, so the simple probability we want to do like what we're aiming for, what you want over the whole thing, right? So the whole amount. And then the odds, it would be what you want over what's left. So odds will never, like this, if I was trying to get, I don't know, if there was 2 red, 3 blue marbles, and it said probability of getting red, it'd be 2 out of 5. If it said odds of getting red, it'd be 2 to 3. So the difference between odds and probability are that, remember. In 12.2, we did permutations. So the permutations were where the order matters, right? So we tried to be pretty straightforward with your test. We don't want to try to trick you. But obviously, these are things you've got to be able to identify the difference between. So it doesn't say flat out, this is a permutation and this is a combination. But the permutations are when order matters. So if you're trying to arrange something, if you're trying to figure out how many ways things can be put, and you're using your entire set, so arranging a whole set, like people, I think we've done, like people in a picture or something on a shelf, this is when you're going to use your factorial. So if there's 5 items, then it's going to be 5 factorial. If you're arranging where order matters part of the set, like taking 3 at a time or whatever, that's going to be your P and R. And then we got into the combinations, and this is where order doesn't matter. So you're just trying to do a group, some sort of grouping. Order doesn't matter. And for these, there's no whole set. It's only part of it, and that's your C and R. All right, so any questions overall on that kind of stuff? The other thing in permutations, like the letters of the word. Okay, those are also like permutations. And then with both permutations and combinations, you had probabilities too. Like what's the probability you finish first and your friend finishes second? That's a permutation. What's the probability that you guys finish in the top 2? That's a combination. So you got to be really careful with that kind of stuff. All right, so the homework, the review, you're saying 8 and 9 got cut off, right? Let me see what it looks like. Oh, so the number was 24 and 13. That's what's there. So obviously now you can see it. The solutions become available now, like they were available as of 8 a.m. this morning, so you can check your answers. But if you guys have questions on these, now's the time to ask. Again, this is 12.1 up until the bottom here. This is all 12.1. So this is like the possible number of outcomes. Possible number of outcomes is just figuring out how many there are. If there's more than one choice, you're going to multiply out the number of outcomes for each one. And then you've got the probability with your like spinner. That's your, your simple counting probability. And then the odds, which are like 8 and 9. Pull this out. Oops. 21. Yeah. That's not from this section though, right, Lewis? Yeah, I'll get to that in a second. Okay, then came the movies. So now you're looking at a percentage based on a chart. This is a great standardized test question. I love charts, especially ACTs. So A is 45 over 500 or 9 out of 100, and B is 37 out of 50. Please, please, please pay attention to the wording. On the questions on the test, it will either say represent your answer as a fraction in simplified form, and you would be entering it as like 9/100, or it will be multiple choice, and obviously it's going to be clear which way it is. But if it's open-ended, please make sure how it tells you to enter in your answer. All right, 12.2 was your permutations. So the letters in the word for tack, all 4 would be that 24, but 2 at a time is your P42, that's 12. Remember that you want to be practicing whatever calculator you're going to be using on Thursday, because if you get something brand new calculator-wise, I'm obviously not going to be able to coach you through using it, so you want to make sure you're ready to go. Then came your simplifying of your factorials, and then the questions like P and R's. You are going to have questions that are straightforward like that. You need to make sure for the work for those questions, you're either like writing out what you typed in your calculator or taking a picture of what you typed in your calculator. So if you're using scrap paper that's just paper, then you can just write right on it what you typed in. All right, 25, summer reading list, 6 books to read in what order? So there's a key word there, right, like order. And then 26, an air conditioner repairman has to repair 7 different homes. Destinations are close. Doesn't matter the order in which the repairs are made. How many orders can the repairs be made? So again, that would be permutation because of the order. Okay, and then 12.3, now we're dealing with combinations. So you, again, will get a question that will just be something like C84. You've got to know how to type that in the calculator to get your answer. 16, 17, 18 go between combinations and permutations, so it's a great way to practice the wording on it. 16 says, how many ways can the 5 students be selected? So this is 5 students and not in a way that it's position 1, 2, 3, 4, 5, but just the group of 5. So that's combination. 17, you're running for a specific position. 3 different positions, so each of those is different, which is the permutation. 18, and how many ways can you complete the quiz? It doesn't say anything about the order in which you pick those questions. That's combination. 20 is your greeting card. And then 21, so Lewis is this one. A coffee shop offers an open mic night for poetry. Tonight, 15 people would like to read, but there's only enough time to have 7 people read. 7 of the 15 would like to read our chosen at random. How many combinations of readers from the group of people would like to read is possible? So that's a combination. It doesn't say in what order they're presenting or performing, just what kind of group they can do. So that's a combination. B says you and your friend are part of the group that you would like to read. What's the probability that you and your friend are chosen, and what's the probability that you are chosen first and your friend is chosen second? Which event is more likely to occur? So if for the first one, you've got to figure out what's the probability that you are chosen. No, sorry, what's the probability that you and your friend are chosen? So for you to be chosen, it's 7 out of 15. For your friend to be chosen, because your friend, now there's 6 left, 6 spots left, and 14 to choose from. So that's 6 over 14, which is 1/5. And then B is the probability. This is, remember, we're taking out you and your friend. So we talked about that there was 2 ways to do B. You could either figure out in the bottom the total probability, and then figure out in the top how many of them is just you and your friend, which is just 1. The other way to do it is take the total in the bottom, and then from the top take out you and your friend. And that becomes the 1 out of 210. So that is your permutation. And then when you compare these, the probability you and your friend are chosen are more likely than you are chosen first and your friend is chosen second, because the order there is important. So I would say, if you want some additional practice, that your warm-ups, if you saw a question appear in the notes and the warm-up, I would definitely review it. Obviously, the wording is going to be different, but the general type of question might be the same. And then you've still got your homework questions on there too that should help. So I would go back through all that stuff. And then I have a Kahoot for us. So if there's no other questions on this. Yes. Go ahead, Camilla. Hang on. 20. So greeting card company packages 4 different cards together that are randomly selected from 15 with different animal on each card. What's the probability that one of the cards in the package is the card that has the dog on it? So you are choosing 4 of the cards, right? So that's your combination, which would be 210. And then with the dog, it's 1 less, right? So you're taking away the one that has the dog from the total number of cards that are left and the total number of options that there are. So that's why the combination falls to C93. For the hardest part for me is when I say, well, what's the odds that it's going to be a dog? I think I'm trying to figure out what the odds it's a dog. But really what you're trying to do by doing that is take the dogs out of the options. So your overall options, which is how it begins, is still the C10-4 because there was 10 different, right? 10 different cards, 4 different, 4 that you're choosing from. So that you're good on that, right, Camilla? Like the combination, the denominator is the total, right? But then in order to figure out which one, what's likely that it has the dog on it, you've got to take the dog out of the options. So you're assuming the dog is chosen. And if that's the case, how many are left? And that's 9 because the 10 before lost 1, so it becomes a 9. And 4 comes to 3 because you took that dog out. So now the numerator is 84. So when you're looking for something specific like that, figure out what happens when I remove that. If it was a dog or a cat, I would take 2 off of the total and 2 off of the number selected. So like if it was a dog and a cat, it'd be 8 and 2 for the numerator. Does that make sense? Okay. Because it's not just saying like, if this is like a finish, right? And it's 2 people and you're trying to figure that, that's when it becomes like there's only 1 chance of that happening. That becomes 1 over the total amount, right? But if you're saying you're taking a certain number at a time and you want to figure out what's the chances that something that is going to get picked, you want to remove that something from your set and that becomes your numerator. Does that make sense? Yeah, okay. All right, so let's go to... Yep. Yep. There's not experimental, there's not a question like that. That just means like, so theoretical means what it, oh, hang on, so loud. Ooh. Theoretical, Sophia, just so you know, like, it's not on your test, but theoretical means all the stuff that we just did is theoretical. You're trying to figure out probability based on what it should be. That's theoretical. So if I'm rolling a die, it should be 1/2 to roll. To flip a coin, it should be 1/2 to land on tails, right? That's theoretical. But then what happens if I actually flip the coin 10 times and I land on heads 6 of those 10 times? That's experimental. And that necessarily doesn't have to match. Does that make sense? No, theoretical is on your test. Right. No, so that would be 6 times, it would be 3 out of 6 times, so it would be 1/2. It's what it should be, not what it actually is. I don't know if that makes, wait, hang on, let me turn this off because this is loud. Shush, okay, so everything that you'll answer on your test is based on straight up theoretical probability, not gathering data from a chart and actually experiment. Does that make sense? Yeah, because like if you just go back to heads, tails, theoretically, it should be a 50-50 shot every time, right? It should be 50% or 1/2 that you land on tails every single time. But it's not always true. And that's the difference between theoretical probability and experimental. Experimental would be what your actual results are, and theoretical would be what your overall probability should be. This test is going to focus on just theoretical. So if it's like, flipping a coin, then it is 1 out of 2 chances to get heads. A coin is tossed and a die is rolled with the probability that the coin shows tails and the die shows a number greater than 3. So you've got a coin and you've got the number die, like a dice that you would roll. The coin's got heads or tails. And then the dice is 1, 2, 3, 4, 5, 6. So you could literally match like heads up with all of them, tails up with all of them, and count how many there are. Or to figure out the total number of combinations, you can do the 2 options that are there for the coin and the 6 options that are there for the dice. So the bottom number is 12 to begin with, right? Because that's how many different combinations there would be. Then you got to figure out how many of them shows a number greater than 3. So I'm ignoring all of this. God bless you. And tails. So I'm ignoring heads, which means tails can go with 4, tails can go with 5, and tails can go with 6, or 3 options out of the 12, which is 1/4. So that's where that answer comes from. Questions on that one? Yes, you mean to get the probability of each? Yeah, so we didn't do the and probabilities yet where you have to multiply those probabilities out, but that's exactly how you do that. Absolutely. Yeah. If the word says and, so if the question says and not or is different, and you multiply or you add. But we didn't get into that. That's actually in the next section, which I don't know if we're going to get to, but that's what the difference is. Yes. Okay, then the next one. Said a box contains 2 red, 10 blue, and 4 pink shirts. A shirt is drawn. Find the probability you pick a red or a pink shirt. So I want to do the number of red and the number of pink over the total number of shirts that are in the drawer. So it's 12 plus 4, which means the bottom number is 16. And then I want either a red, which is 2, or a pink, which is 4, which means this is 6 over 16, or 3/8. And Camilla, the way that you're doing it, it would be a plus because it's an or. So it'd be the probability of a red, which would be 2 out of 16, plus the probability of a pink, which is 4 out of 16, and you add them when it says or. So you multiply when it says and, you add when it says or. All right, and then the last one. Okay, find the probability of, if the probability of an event occurring is 2 out of 5, what are the odds in favor of the event? So if it's 2, 5 for probability, remember this is what you want, and this is your total. So if I want to find odds, I want to do what I want, which is 2 over how many are left besides what I want. So I do the 5 minus the 2, and it's 3. So the odds are 2 to 3. The sum of your odds should always add up to be the total, okay? So if you want to think about it that way. Questions on any of these Kahoot questions? I would say if you got stumped on any of them, it would be a really good thing to go back and review them. Okay, pretty much everything that you'll see on that Kahoot, you could see on your test, obviously different subjects and that kind of stuff. And then also all of your factorials and your combinations. Okay, again, test is Thursday. You need calculators. You're going to need scrap paper, whether you use Notability or you use a hard copy. Doesn't matter to me. Make sure you're getting on with your second device so you can use your iPad to take your test. And make sure you're in a quiet space because you're going to need to unmute yourselves. Which means, Anna, wherever you are right now, you can't be on Thursday. I could tell, hey, what are sisters for if not to be annoying? It's their jobs. All right, questions again before you leave. And again, remember that today's Zoom call is not going to be published because I don't know if it was some of the people in here trying to be smart and doing some interesting names, or they gave out the code, but I don't want those code names to be published on Zoom, and I can't crop Zoom in the middle, so I can crop YouTube. I will do it there. Everybody's good? Questions? I'm good, Mom. There's it's funny. I think there's 10. Yeah, I know. I'm like, I know in the other, I had to look in the other class because I've made 3 different tests. There are, 10 and then the 11th for the work. So there's 10 questions, 1 for the work. Everybody good? Some of them multiple choice, some of them open-ended, so just really pay attention to how it says to format your answer so that it can grade it correctly.